So adding Epsom salt to a dead lead acid battery does not desulfate the plates or increase the amp hour capacity, but it does increase the voltage and also allow you to pull more amperage from the battery, which is great for starting a vehicle. I've done the tests and I come to this conclusion. Here's how. So here's the guinea pig of today's experiments. We shall be using this battery. It is a 4 amp hour 12 volt battery. I think it's a motorcycle battery. When I originally got it, it was at 0.4 volts, and I brought it up to voltage as high as it'll go. Then I desulfated it for several months, and it'll hold for several weeks at 12.2 volts, which is awesome. But before we add the Epsom salt, we need to know how much capacity it has. So let's discharge it with my IMAX B6 battery charger, and we will count up how many milliamp hours of current it has. See right there, it's counting it up. Well, it has stopped. It's gone back up to almost 12 volts, and it got 950 milliamp hours, so almost an entire amp hour. So it's about a quarter of the power it should be. Let's test the voltage under load. Now that's the voltage that it sits at after a little while of charging. And let's put an 1.8 amp load onto it and see where it falls down to. Let's say 11.79. That's pretty good. Now that we have established that this battery has 950 milliamp hours of capacity, and where it should have 4, let's charge it up while we make the electrolyte. And for the electrolyte, we shall start with some hot water. I'm putting it in a 1000 milliliter boiling flask. Get a funnel, add some Epsom salt to it. That's the main problem with Epsom salt, is it chunks up pretty bad. Oh, there's a spoon in there. That's why. Never mind. We want to have it plenty of Epsom salt, because the thing is, we're only going to be putting a small amount of this into the battery. But I'll be using it for a lot of batteries, so it's okay. Now I'll put a cap on it. Oh, wait. Almost forgot. The stirring magnet. And we shall turn it on for stirring. Yeah, that should be good enough. See how it's all nice and clear? It dissolved nicely. And now that we have this mix, we can take some of it. I'll say 1 milliliter. I'll put it in each cell. Then we want to mix up the battery a little bit so it sloshes the chemical around and makes it to where it's equally distributed throughout the electrolyte. The battery's been charging for a little bit, and it is hovering at 12.6-ish volts, which is pretty awesome. That's a huge step up from like the 12.2 volts. So let's do a discharge test, like before. Now that's odd. It only gave 819 milliamp hours of capacity. I was hoping it'd give even more. And the voltage has gone back up to 11.83 volts. Not bad. Well, I believe that perhaps I just didn't charge it good enough the first time. So let's bring the voltage and let's stop charging it and see what voltage it gets down to. So the battery settled down to 12.71 volts. And let's do the lamp test again. .06. Awesome. Battery is back up to 12.71 volts. It's pretty awesome because evidently the Epsom salt is raising the amount of amperage it can produce. So at a given load, it will dip in voltage a lot less. So it's a lot more stable. Now let's do the discharge test once again. Well, now on this run, I went to 978 milliamp hours of current. That is amazing, and it went up to 12 volts. Perhaps this takes several cycles to work. I've heard that before, so let's charge it and do another cycle. So I'd have to say that's probably pretty nicely charged now. Let's see what voltage it gets down to. And the battery's only settled down to 12.85 volts after about 20 minutes of sitting. So let's discharge it. So this time it lasted almost over 2 hours and got over an amp hour. So that's awesome. Now, the main issue I'm seeing with it right now is that this is only gaining like at the most 200 milliamp hours of current each cycle. So I'm going to run it through several cycles. I'm going to probably use a big source of load. And now that load will be this 16 amp load right here. This is a window defroster for in the winter, so you plug it in and you defrost your windshield if it's all iced over. But it pulls 16 amps of current at least, and that would be a good way to discharge this, because I'm going to discharge it and charge it, discharge and charge it without really calculating anything. I'm going to do that for a few cycles, and then after about 5 or 6 cycles I'm going to test the capacity again, and we'll see how much more power it has. So now the battery's charged. I'm not even going to wait for the battery to equalize. And so we have two settings. We have this one, which is just the fan, and that pulls about, I think, half an amp or so. And now we have fan and heater, which pulls about 15 amps or 16 amps, can't remember. And that should only take like 2 minutes to burn up that entire 1 amp hour of capacity. So that's awesome. Wow, it's going down pretty fast now. So let's say 9's good enough. There. Yeah, about there. So let's charge it again. And I will repeat this 5 times. Over the weekend, I have discharged this 5 times and charged it again. Then yesterday evening, I just let it sit at 13 volts and it charged it a little bit. And now after a day, it has settled down to 12.43 volts. So that might be a little lower voltage than it was before, but let's do a discharge test to see how much capacity it has. Well, that test wasn't very promising. Evidently the day of it sitting, its capacity went back down. That's interesting. In conclusion, Epsom salt added to a lead acid battery increases the electrolyte's reactivity. Because let's say this battery has 75% of its surface area of the plates sulfated, and then the other 25% of the surface area of the plates is not sulfated. All of your capacity and reaction is coming from that remaining part of the plates that's still usable. And so this increases the reactivity, which kicks that into overdrive, so even that small amount of plate surface area can give more power. So that'd be great for starting a vehicle, but it does not give it more capacity, unfortunately. But I do have to say, this would be good for a deep cycle battery nonetheless, because it might help keep the voltage up, which would help to stop sulfation. Because if you have your battery down to like 12.2 volts or any lower, it starts to sulfate more and more. And lastly, the main downfall I could see with this is that you could make the electrolyte too reactive. If you add too much Epsom salt to the battery, it would become too reactive, and you could inflict your battery with a lot of corrosion that would shorten its lifespan even more. I mean, if it's already a dead battery though, it's fine, because it's gonna die anyway. But this is the main reason why most battery acid is only 10% sulfuric acid. If you had pure sulfuric acid inside of your batteries, that would just destroy your batteries, plates, and the connectors in between the plates. And so you want to make sure you don't put too much Epsom salt into there, unless you don't mind maybe corroding your battery. Well, I hope you enjoyed this video, and thanks for watching. See ya!